Hello, happy people. This is Mr. Wilcox coming to you from my kitchen table again. This will be the last video for this fourth week of virtual learning here in Algebra 1. We have learned the meaning of exponents. We've used the meaning of exponents to multiply. And today we're going to learn the properties of multiplying so that it makes it easier for us to multiply. There are three properties of multiplying exponents. In total, there will be 7 properties for exponents. Today, we are going to learn the first 3. And our first property is the products of a power property. So I'm going to pause for a second to let you write this property in your notebook. And when you're done, just hit play on the video again. So the products of a power property just states that if you have 2 powers with the same base and you're multiplying them, all you have to do is add their exponents. So if we have 5 to the 6 times 5 cubed, yesterday we would have written 6 fives times 3 fives, which would have gave us 9 fives, or 5 to the 9th. Today we can see that easier by just taking our 6 plus our 3 to get our 9. And remember, if we have a number as our base of our exponent, we have to simplify because we can. So 5 to the 9th is 1,953,125 simplified. So I have a couple examples here of using our product of a power rule. So if I have 3 to the 7th times 3 squared, here's what we're going to do. We're going to take and keep our base the same, so 3. And then we're going to add our exponents. So if I take 7 plus 2, I get 3 to the 9th. And if I put 3 to the 9th in the calculator, because I need to, because 3 is a number, and I know what 3 times 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 3 is, it is 19,683. So that expression simplified is that number. If I take x squared times x to the 6th, I'm going to keep my base the same and add my exponents. So 2 plus 6 is 8. There is nothing more simple than x to the 8th. So that is our answer. So x squared times x to the 6th, x to the 8th. For 2y to the 4th times 5y, if there is no exponent on a power, the hidden exponent is 1. So I really have 2y to the 4th times 5 times y to the 1st. So since 2 and 5 aren't the same base, they're just coefficients out front, we're going to just treat them like normal numbers because they are. So I'm going to take 2 times 5, which is 10. Be careful not to add them. We're still multiplying. They're not exponents, so do not apply the rule of exponents to regular numbers. Y to the 4th times y to the 1st, those are 2 powers with base y. These are exponents, so I'm going to add them. 4 plus 1 is 5. 10y to the 5th is as simple as it gets, so that is our answer. Remember to be careful for the numbers out front or our coefficients to not use the rules of exponents. Make sure if it says to multiply them, today you're going to multiply them. And make sure you're adding the exponents in this case. All right, our second property then is the power to a power rule. I am going to pause for a second so you can pause the video and write this in your notebook. All right, so the power of a power property states that if I have a power and I raise it to another exponent, I multiply the exponent. So whenever you have an exponent outside a set of parentheses, you're always going to multiply every exponent inside the set of parentheses. So if we have 3 to the 4th and we square that, yesterday we would have wrote 3 to the 4th times 3 to the 4th, and then 4 3s times 4 3s to get 3 to the 8th. Today, you just have to multiply your 4 times 2 to get 8, so we still get 3 to the 8th, which if you simplify is 6,651. So we're multiplying the number outside by the exponent inside. All right, I do have a couple examples of the power of a power rule. Let's go ahead and write these down. All right, if I take 4 squared and I take it to the 7th power, I'm going to take the exponent outside 7 and multiply it by the exponent inside 2, which gives me 4 to the 14th power. And if I put that in a calculator, I get a very big number, which is 268,435,456. So there is our most simplified answer. It's a very big number, but that's okay. Exponents get very big very quickly. If I take n cubed to the 6th power, I'm going to keep my base the same, take my exponent outside, my 6 times my 3 to get 18. And n to the 18th is already in its most simplest form, so that is our answer. All right, our last rule for the day is the power of a product rule. It's pretty much the same as the power of a power rule, only it just states that if there's more than one power in the parentheses, we're going to multiply that exponent outside by every exponent inside the parentheses. So if I had 2x and I squared it, yesterday I would have went 2x times 2x. So, and then had counted the 2's and the x's, get 2 squared times x squared. Today, all we have to do is we have to take that exponent outside, multiply it by every exponent inside. These both have hidden ones. So I get 2 times 2 times 1 is 2. 2 times 1 is also 2. So 2 squared is 4. So I would get 4x squared. I have a couple more examples for you to hopefully show you better how this works. So the first example, go ahead and write these in your notebook. Sorry. So the first example is xy squared. So if they don't show the exponent, remember there's a hidden exponent of 1. So I do suggest you write those on all of your powers so that you don't forget that it's there. So now I just need to take that 2 outside and multiply it by every exponent inside. So I will get 1 times 2 on my x to get 2. And on y, I also have 2 times 1, which is 2. And x squared, y squared, those are 2 powers with different bases. So that's as simple as we get. So x squared, y squared is our solution. All right, 2x cubed to the 4th power. Even on that 2, there's a hidden exponent of 1. So we're going to write that in so that we can multiply all of our exponents inside the parentheses by the exponent outside. So if I do that, I'm going to get 2 to the 4th power, because 4 times 1 is 4, and x to the 12th power, because 4 times 3 is 12. Not quite done yet because we do know what 2 to the 4th power is. If I take 2 times 2 times 2 times 2, I get 16. And then x to the 12th doesn't get any simpler. So our answer here is 16x to the 12th. So those are our 3 properties for multiplying exponents. Either you're going to add exponents because you're multiplying two powers with the same base, or you're going to multiply your exponents because you have parentheses and you're going to take the one outside times everything inside. So I hope you are happy, I hope you're healthy, and I hope you have a great day.